Question 2, we have this transform sine wave, k sine x on 2. It really helps to understand what has happened to a normal sine wave. So if we create the wave shape for a sine, and we know it goes to a maximum of 1 and a minimum of -1, it goes to 2 pi for 1 period, which means halfway is pi, and a quarter of way is pi on 2, and 3/4 is 3 pi on 2. Pi on 2, of course, is where we have a maximum of 1, and 3 pi on 2 is where we have a minimum of -1. So the first thing we hopefully notice is we're multiplying a sine wave by a number k. We don't know what that number is, but it's a number, k. And what that does is it expands the wave away from the x-axis. So instead of going to a maximum of 1, it's going to go to a maximum of k. And instead of going to a minimum of -1, it's going to go to a minimum of -k. So now we have to work out what is a half x doing to the function, to the generic function. And if you remember, it does the opposite of what it looks like. It doesn't make the wave as half as wide as what it was. It actually, you do the inverse. So the inverse of a half is 2. So it's actually making the sine wave twice as wide as what it originally was, which means one period doesn't go to 2 pi anymore. It now goes to 4 pi because we multiply it by 2. And so on our wave, we can put in that one period is 4 pi, a halfway will be 2 pi, a quarter will be pi, and 3/4 will be 3 pi, which leads us to just reading the point of A as 3 pi and -k. For part B, we're taking the function and we're applying a sequence of transformations. So the translation of 2 units in the negative y direction simply means the whole function moves down by 2. And what we do for that is we have the function and we just subtract 2 from every y value. So that's it. The reflection in the x-axis means everything below the axis, all the negatives will become positive and all the positives will become negative. And how do you do that? Well, we just put a negative in front of the whole function. We have moved the function down by 2, so that negative applies to everything, the function minus 2. Okay, so applying that to what we have, we get y is negative in brackets, the whole thing, k sine x on 2 minus 2. The minus sign distributes, so it's going to make the -2 positive, and it's going to make the k negative. And we end up with the new equation of the curve, y equals 2 minus k sine x on 2. But that was the first part. The second part was determine the coordinates of the point A after it's done this transformation. Okay, so we can just do exactly what we did to the wave. We can say, well, the point's going to move down to, and so it was at -k, so it will move to -k minus 2. Then the reflection in the x-axis is going to take all the negative y's and make them positive, and all the positive y's and make them negative. And so our y value is -k minus 2, so we put a negative in front of that. That's going to make the k positive. It's also going to make the 2 positive, and we end up with k plus 2. Well, that's our translated point. The x value is 3 pi, and the y value is k plus